Most people think natural disasters come out of nowhere. But in reality, the Earth is giving us signals all the time. We just don't always know how to read them. In this video, I'm going to explain what's really happening beneath the surface of Hunga Tonga, why it matters, and what it means for people who live there. This is Geohazards Explained. What you are about to watch is the most powerful volcanic eruption recorded by modern instrumentation in human history. Not the biggest ever, but the biggest our satellites, our sensors, and our global monitoring networks have ever captured in real time. And it didn't just erupt, it generated a tsunami that crossed every ocean basin on the planet. It sent a shockwave around the Earth, not once, not twice, but at least 3.5 times, and it erased an entire island from the map. This is the Hunga Tonga Hunga Ha'apai eruption update. A large tsunami occurred, and the more scientists study what happened on January 15, 2022, the more alarming the picture becomes. Stay with me, because this one is unlike anything we've ever covered on this channel. To understand what happened, we need to go back a few weeks before the main event. The Hunga Tonga Hunga Ha'apai volcano sits in the South Pacific Ocean, about 65 kilometers north of Tongatapu, the main and most populated island of the Kingdom of Tonga. It's part of the Tonga Kermadec volcanic arc, one of the most geologically active subduction zones on Earth, where the Pacific Plate dives beneath the Indo-Australian Plate. This is a region that has been building volcanic pressure for millions of years. The volcano itself is mostly underwater. It rises 8 kilometers from the seafloor and stretches roughly 20 kilometers across, topped by a submarine caldera about 5 kilometers in diameter. For most of its history, only the very rim of that caldera poked above the ocean surface as two small islands, Hunga Tonga and Hunga Ha'apai. But between 2014 and 2015, a Surtseyan eruption, the kind where magma meets seawater in explosive bursts, built a brand new island connecting the two. Scientists from NASA and Columbia University had been monitoring this new landmass closely ever since. Then, on December 20th, 2021, the volcano woke up. A new eruption began, sending ash plumes into the stratosphere. Airlines were warned. Tonga's capital, Nuku'alofa, could see the ash cloud from 70 kilometers away. Over the following weeks, the activity was intermittent, sometimes intense, sometimes quiet. By early January 2022, the island had actually grown by about 60% compared to before the December activity started, according to NASA Earth Observatory. New ash and tuff were piling up. The volcanic cone was expanding. And then, on January 11, 2022, the Tonga Geological Services declared the volcano dormant. They thought the worst was over. They were wrong. On January 14, 2022, the volcano roared back to life. A massive subaerial eruption began at 4:20 in the morning local time, sending a mushroom-shaped plume of gas, steam, and ash 18 to 20 kilometers into the stratosphere. The plume expanded radially to over 240 kilometers in diameter. Geologists on a nearby boat watched in real time as Surtseyan pulses ejected dense, dark material into the air and pyroclastic flows, fast-moving rivers of hot gas and volcanic debris, expanded across the ocean surface. A national tsunami warning was issued. Waves reached 15 meters in elevation on Good Samaritan Beach. The eruption continued for more than 12 hours, but that was just the opening act. The following day, January 15, 2022, at 5:14 in the afternoon local time, the volcano detonated. And I want you to understand what that word means in this context. This was not a gradual escalation. This was a detonation, a cataclysmic phreatoplinian explosion triggered when the caldera's northern rim partially collapsed, allowing an enormous volume of cold seawater to rush into a superheated magma chamber. The temperature of that magma exceeded 1,000 degrees Celsius. The seawater was around 20 degrees. The result was an instantaneous, catastrophic steam explosion of almost incomprehensible scale. According to NASA's Goddard Space Flight Center, the energy released was equivalent to somewhere between 4 and 18 megatons of TNT. NASA determined the eruption was hundreds of times more powerful than the atomic bomb dropped on Hiroshima. The eruption column punched 58 kilometers into the mesosphere. Some satellite datasets suggested portions may have reached as high as 57 kilometers, making it the highest volcanic plume ever recorded. The eruption was rated at least a volcanic explosivity index of 5. Scientists described it as a magma hammer. The volcano produced a series of 4 underwater thrusts and displaced 10 cubic kilometers of rock, ash, and sediment. That is an almost incomprehensible volume of material moved in a matter of minutes. The explosion was heard in Samoa, 840 kilometers away. Residents in Fiji, over 700 kilometers distant, described the sound as thunder. The boom was heard in New Zealand, 2,000 kilometers away, arriving 2 hours after the eruption. And here is the detail that still stuns me. The explosion was heard in Anchorage, Alaska, 9,300 kilometers from the volcano. Booms were reported as far away as the Yukon in Canada, nearly 9,700 kilometers distant. This was the largest atmospheric explosion ever recorded by modern instrumentation. In recent centuries, only the 1883 eruption of Krakatoa rivals the atmospheric disturbance it produced, according to NOAA's National Centers for Environmental Information. Between 5 p.m. and 6 p.m. UTC on January 15th alone, the Vaisala Global Lightning Dataset recorded 200,000 lightning flashes inside the eruption plume, 200,000 lightning strikes in a single hour. The sky above Tonga was on fire. Now let's talk about the tsunami, because this is where the story gets even more extraordinary and more terrifying. Within minutes of the main eruption, tsunami waves began striking the islands of Tonga. The waves reached up to 20 meters, 66 feet, in height on the main island of Tongatapu. On the uninhabited island of Tofua, run-up heights reached 45 meters, that is 148 feet of water surging inland. A post-tsunami field survey conducted by international scientists in March 2022 confirmed the maximum tsunami height on land was approximately 22 meters on Tofua Island, according to NOAA NCEI. All 7 beach resorts along the northwestern tip of Tongatapu were completely leveled. The islands of Nomuka Iki, Mango, and Tonumea were devastated. Ocean surges washed over low-lying areas, and every single home on Mango Island was destroyed. The total damage in Tonga reached $182 million USD, with the vast majority caused by the tsunami rather than the eruption itself. But here is what made this tsunami scientifically unprecedented. It wasn't just a local event, it crossed every ocean basin on the planet. And it did so in 2 completely different ways simultaneously. The first mechanism was a classic volcanic tsunami, the direct displacement of massive volumes of seawater by the eruption itself. The caldera collapse and the explosive underwater thrusts pushed enormous walls of water outward in every direction. This is the type of tsunami we typically model and prepare for, but the second mechanism was something far more unusual. The eruption generated massive atmospheric pressure waves, specifically a type called lamb waves, that traveled at the speed of sound, approximately 710 miles per hour. As these pressure waves raced across the ocean surface, they pushed the water ahead of them, creating what scientists call meteor tsunamis. Tsunamis generated not by seafloor displacement, but by atmospheric disturbance. According to the U.S. Geological Survey, this dual tsunami mechanism genuinely surprised the scientific community. Here is why that matters. Tsunami warning systems are primarily designed to detect and respond to earthquake-generated tsunamis, which account for nearly 90% of all historical tsunamis. The atmospheric component of the Hunga Tonga event moved faster than any standard tsunami warning model predicted. In Japan, tsunami waves arrived more than 2 hours earlier than expected, not because the classic tsunami was fast, but because the meteor tsunami, driven by atmospheric pressure waves traveling at 700 miles per hour, arrived first. Waves about 1 foot high were recorded at Japan's Ogasawara Islands at 8:20 p.m. local time, when scientists had predicted arrival around 10:30 p.m. The tsunami reached Fiji, American Samoa, Vanuatu, New Zealand, Japan, the United States, the Russian Far East, Chile, and Peru. In Peru, more than 10,000 kilometers from the eruption, 2 people drowned when 2-meter waves struck the coast. These were the first tsunami-related deaths in the far field in over a decade. Damage was also reported in Canada, Chile, Hawaii, California, Mexico, and New Zealand. A NASA JPL study using Sentinel-6 satellite altimetry confirmed the mechanism. The eruption caused a lateral movement of air forming pressure waves, followed by a proportional displacement of ocean water to fill the newly formed crater, which then triggered the tsunami. The tsunami reached Tonga's main island in just 10 minutes. It reached Fiji in 50 minutes. While the tsunami was racing across the Pacific, something else was happening in the atmosphere above. The eruption generated a pressure shockwave that circled the entire globe. Weather stations around the world recorded the sudden spike in atmospheric pressure as the wave passed. In New Zealand, the pressure amplitude reached 7 hectopascals. In Australia, 6.9 HPA at Lord Howe Island. In Switzerland, 12,000 kilometers from the eruption, a pressure fluctuation of 2.5 HPA was measured. In the United Kingdom, just over 2 HPA. The shockwave circled the Earth at least 3.5 times, according to measurements from Japan and Utah, and was recorded at least twice at the Blue Hill Meteorological Observatory in Massachusetts. Let that sink in. A single volcanic explosion sent a pressure wave around the entire planet multiple times, and back at the source, the island was gone. Within 5 hours of the main eruption, the central part of the Hunga Tonga Hunga Ha'apai island landscape had completely disappeared beneath the ocean surface, according to Sentinel-1 SAR satellite analysis published in scientific reports. The new island that had formed between 2014 and 2015, the one NASA scientists had been studying for years, was obliterated. Large chunks of the 2 older islands, Hunga Tonga and Hunga Ha'apai, were also destroyed. The volcano had consumed itself. As of the most recent overflight by Tonga Geological Services in February 2026, only small remnant portions of the islands remain above the ocean surface, and those are continuing to erode, according to the Smithsonian Global Volcanism Program. The human toll in Tonga was devastating, but, remarkably, lower than it could have been. 7 people died, 19 were injured, and others were reported missing. The relatively low death toll was attributed to several factors. The eruption occurred during daylight hours. Moderate tsunami waves arrived before the largest and most destructive wave, giving people precious minutes to flee, and Tonga's long-standing practice of tsunami drills and awareness campaigns saved countless lives. But the environmental damage was severe and long-lasting. Volcanic ash blanketed 99% of the country. The ash was several centimeters thick in Nuku'alofa and lasted approximately 10 hours. The underwater fiber optic cable providing Tonga's internet access was severed, cutting the country off from the world for weeks. Satellite terminals were buried in ash. 1 year after the eruption, Reuters reported that Tonga's coral reefs were still largely silent. The volcanic ash had smothered reefs, depriving fish of feeding areas and spawning beds. Large boulder corals had been knocked over by the tsunami, creating fields of rubble. The crackling, snapping sounds of a healthy reef, the sounds of shrimp and fish foraging, were gone. The UN's Food and Agricultural Organization estimated the eruption cost Tonga's fisheries sector $7.4 million. The Tongan government sought $240 million for total recovery. But the scientific revelations from this event have been extraordinary. The eruption injected an estimated 146 million tons of water vapor into the stratosphere, increasing the total amount of global stratospheric water by 10% in a single event, according to NASA's Paul Newman, Chief Scientist for Earth Sciences at Goddard Space Flight Center. Water vapor can linger in the stratosphere for up to a decade, trapping heat and potentially depleting ozone. Scientists are still studying the long-term atmospheric effects. The eruption also forced a complete rethinking of volcanic tsunami warning systems. The USGS noted that interim volcano tsunami alert procedures have been developed specifically because of the Hunga Tonga event. The dual tsunami mechanism, classic displacement plus atmospheric meteor tsunami, exposed a critical gap in global early warning infrastructure. Tsunami warning systems were simply not designed to handle a volcanic source moving at the speed of sound. So what does all of this mean for us going forward? The Hunga Tonga eruption was described by scientists as a once-in-a-thousand-year event for the Hunga caldera. But the Tonga Kermadec volcanic arc is one of the most active subduction zones on the planet. There are dozens of submarine volcanoes along this arc, many of them poorly monitored, many of them capable of similar behavior. And the mechanism that made Hunga Tonga so catastrophic, the sudden collapse of a caldera rim, allowing massive seawater intrusion into a superheated magma chamber, is not unique to this volcano. The USGS's Eric Geist put it plainly. This was an unusual event that could have taken many more lives. The warning systems worked, barely. The death toll was low because of preparation, education, and a degree of luck. But the scientific community is now acutely aware that the next major submarine volcanic eruption could generate a tsunami that outpaces every warning system we currently have in place. The LAM waves from Hunga Tonga circled the globe at 710 miles per hour. A meteor tsunami driven by those waves can arrive hours before any standard tsunami warning model predicts. If the next event of this scale occurs near a densely populated coastline, near Tokyo, near Los Angeles, near Lima, the consequences could be catastrophic on a scale that dwarfs what we saw in Tonga. This is not a hypothetical. This is a documented, scientifically confirmed mechanism, and it is one that our global warning infrastructure is still catching up to. The Hunga Tonga eruption was the largest atmospheric explosion ever recorded by modern instrumentation. It generated a tsunami that crossed every ocean on Earth. It erased an island. It sent a shockwave around the planet 3.5 times, and it exposed a gap in our global tsunami warning systems that scientists are still working to close. This event changed volcanology. It changed tsunami science. And it should change how all of us think about the risks hiding beneath the ocean surface. Geologic hazards can't be eliminated, but they can be explained. And when we understand how the Earth works, we make better decisions about where we live, how we build, and how we prepare. If this helped you see the ground beneath your feet a little differently, consider subscribing for clear, honest explanations of Earth's most powerful processes. This is Geohazards Explained, and I'll see you in the next one.